In this video demonstration, I'm going to show you how to solve a 3 by 3 system of equations. Now, what does that mean? A 3 by 3 system is basically three variables, an x, a y, and a z, in a system that has three equations in it, all of which have, the variables in question. Okay, so really what we're trying to do is find the intersection between all three of these equations. And there's a procedure that you need to follow that you can do that. I'm going to go over that with you in this problem. Now, organization is going to be really huge here because there's really lots of steps. So to keep it organized, let me go ahead and label things for you. I'm going to label the first equation A, the second one B, and the third one C. Okay, so how would we do this? Well, just like in a regular system, a 2 by 2 system, you're going to take two equations and eliminate one of the variables. So we have to choose two of these equations and eliminate a variable of choice. So let's do, let's just choose A. I have 2x minus y plus z is equal to 10. And let me see here. Why don't we eliminate let's choose B. Let's go with 4x plus 2y minus 3z is equal to 10. Now you have your choice. You can eliminate the x's, you can eliminate the y's, or you can eliminate the z's. I think I want to eliminate, in this case, let's see here. Why don't we eliminate the y's? Okay. Now in order to do that, I need to multiply this top equation by 2. So go ahead and do that. Oops, put that out of the way. And that's going to give me, let me move this a little bit over there. That's going to give me 4x minus 2y plus 2z is equal to 20. And down here I've got 4x plus 2y minus 3z is equal to 10. Now you can add or subtract equations at this point. If I were to add, the y's would eliminate. If I were to subtract, the x's would eliminate. And again, it doesn't make any difference which one you do. I'm going to add just because it's easier. So the y's go away. And I get 8x, add those two, you get minus z, add those two, and you get 30. Now that equation is an important equation. We're just going to highlight it and leave it there for the next round of things that we need to do. So there's my first secondary equation. Let's try another one now. In my third step, what I need to do is I need to go back and pick up the equation that I didn't use, which is C. So let me just write that up. X minus 3y plus 2z is equal to 8. And I need to pair it with either one of these two equations. Okay, and it doesn't make any difference which one you pair it with. I think I'm going to pair it with the A just because it's easy. And I get 2x minus y plus z is equal to 10. Now this is important. You have to eliminate the same variable that you eliminated up here. So when I look at this, I have to eliminate the y. So let's do this by multiplying. I think I'm going to multiply it by negative 3. And let's just see what happens when I do that. I'm going to get negative 6x. I'm going to do this part down here. Plus 3y minus 3z is equal to negative 30. Up here, I'm just going to rewrite that. That's going to be x minus 3y plus 2z is equal to 8. If I add those two equations, those eliminate. Add those, you get negative 5x. Add those, you get minus z. Add those, you get negative 22. So now I've got two equations. Look what I've done. I've kind of reduced three variables and three equations to two variables and two equations. And that's kind of easy to do, isn't it, to solve. I can use elimination, substitution, graphing. I could even use Cramer's rule and still solve it. So let's rewrite these two over here. I've got 8x minus z is equal to 30, and a negative 5x minus z is equal to a negative 22. When I look at those two equations, what do I want to do with them? Well, I want to eliminate the z here. It seems like it'd be the easiest. And I would do that by subtracting them, right? Because negative z minus negative z makes them go away. 8x minus a negative 5x is a positive 13x. 30 minus a negative 22 means to add 22, so it's 52. Divide both sides by 13. I get x is equal to 4. Well, that's pretty handy. I'm going to take that x is equal to 4, and I'm going to substitute that into one of these two equations over here. Now notice I can't substitute it up here, because if I did, what would happen? I'd still have a y and a z, wouldn't I? And that hasn't really gotten me anywhere. So let's substitute it into one of these two equations. And again, it doesn't make any difference which one you do, because you're going to, they both have to intersect anyway. So I'm going to put 8 times 4 minus z is equal to 30. That's going to give me 32 minus z is equal to 30. Let's subtract it. Z is equal to a negative 2. Excuse me, negative z is equal to negative 2, or z is equal to 2. So there's my second variable that I found. And then from this point on, it's pretty easy. My sixth step, I'm going to substitute x is 4 and z is 2 into one of these three equations, and I'll find the y. All right, let's do that. So let's put it into this equation here. This is the first one. It's equal to 10. I get 2 times 4 minus y plus 2 is equal to 10. That gives me 8 minus y plus 2 is equal to 10. 8 plus 2 is 10. Subtract 10. Negative y is 0, or just y is 0. And there's my answer. I now have, as my final concluding remarks, I've got x is 4, y is 0, z is 2. And that answer, in that order, x, y, z, is called an ordered triple. And you can actually check this answer just by substituting 4, 0, and 2 into any of these equations up here, and you should be able to get the right answer. Okay, I hope that helped. Practice it on the homework problems I gave you, and I'll see you tomorrow.